Welcome back, everyone. Have you ever noticed patterns where each number is multiplied by the same value to get the next one? Such patterns appear in nature, finance, population growth, and many real life situations. These patterns are known as geometric sequences. And when we add the terms of a geometric sequence together, we get a geometric series. So, in today's lesson, we'll learn what a geometric series is, understand its important formulas for both finite and infinite geometric series, and solve a sum. This way, you will have a clear understanding of this important topic and solve questions with confidence. So, let's begin. So, the sum given is find the sum of this sequence. 2 minus 3 plus 9 by 2 minus 27 by 4 plus minus 177147 by 1024. Please note that this is a calculator based question, so you can use a calculator to calculate the answer. Now, before we begin, let's recap or recall the formulas for finite and infinite geometric series. So, the partial sum of a geometric series with common ratio r, where r is not equal to 1 and first term u1 is Sn. Now, the sum is represented by Sn is equal to u1 multiplied by within brackets 1 minus r to the power n divided by 1 minus r, where r is not equal to 1, and sum of an infinite convergent geometric series, again represented by Sn, is equal to u1 divided by 1 minus r, where the absolute value of r is less than 1. So let's begin solving this sum. Just give me a moment. Now here we observe that, now first let us find out whether this is geometric series or arithmetic series. So let's find out the common difference. So if we observe the common difference, D here is, if at all there is common difference, okay, so second term minus first term, minus 3 minus 2, which is minus 5, and again D will be third term minus second term, so 9 by 2 minus 3, which is 9 by 2 plus 3, so 15 by 2. So they are not equal, hence this is not an arithmetic series. So let's find out the common ratio then. So if we observe, the common ratio R is second term divided by first term is minus 3 by 2. Again, R is third term divided by second term, 9 by 2 divided by minus 3, which is 9 divided by 2 multiplied by minus 3. So what do we get? Minus 3 by 2. So common ratios are same, hence this is a geometric series. So this is a geometric series, thus Sn will be, now if we observe, this is a finite geometric series where there are a fixed number of terms n. So we will use the formula Sn is equal to u1 multiplied by 1 minus r to the power n divided by 1 minus r. Now here we know that u1 is first term, r is common ratio, and n is number of terms. But before we calculate the sum of series, we need to find the value of n, which is the number of terms. So here un in a geometric series, the general term un is equal to u1 multiplied by r to the power n minus 1. Now, here the last term or the nth term is minus 177147 divided by 1024 is equal to, the first term here is 2 multiplied by, common ratio is minus 3 by 2 to the power n minus 1. Now what do we observe? So we can write this as minus 177147 divided by 1024, cross multiplying it by 2 is equal to minus 3 by 2 to the power n minus 1. Now if we prime factorize minus 11147, we get, now let me, you can use a calculator also. So what do we get? We will get this as minus 3 by 2 whole to the power 11 is equal to minus 3 by 2 whole to the power n minus 1. Now since bases are same, now I'll solve this here. Since bases are same, now what is the base? Base term is minus 3 by 2. So minus 3 by 2 to the power 11 is equal to minus 3 by 2 to the power n minus 1. Hence, 11 is equal to n minus 1. So this follows n is equal to 12. So the number of terms n is 12. Now we will calculate the value of S12 or the sum of this series. Just give me a moment to erase. So here S12 will be, now U1 is 2 multiplied by 1 minus 3 by 2 to the power 12. Okay, now we'll put a square bracket here. This will be a square bracket. This is 1 divided by, I'll put this equal to sign in its position here. So 2, which is the first term, within brackets 1 minus r to the power 12, and r is minus 3 by 2 divided by 1 minus r. So this will be again within square brackets 1 minus 3 by 2. Now we'll continue to simplify this. So what do we get? We get 2 multiplied by 1 minus 3 by 2 to the power 12 divided by 1 plus 3 by 2. Again simplifying, 1 minus 3 by 2 to the power 12 divided by 5 by 2. Please note that this sum is lengthy. The calculations are really long to get the answer. So we'll continue solving. So what do we get? 2 divided by 5 by 2 will be 2 multiplied by 2 by 5. So this will be 4 by 5 multiplied by 1 minus 3 by 2 to the power 12. And then again, what do we get? We open the brackets. So we multiply each term with 4 by 5. Multiplying each term, we get 4 by 5 multiplied by 1 is 4 by 5 minus 4 by 5 multiplied by minus 3 by 2 to the power 12. Now give me a moment to erase. So we will calculate further. Next step, Sn is equal to 4 by 5 minus 4 by 5. Now within brackets. Now minus 3 to the power 12 is, the value is 531441 divided by 2 to the power 12 is 4096. Okay. Next step, 4 by 5 minus, now if you multiply 4 multiplied by this term 531441 using a calculator, we get 2125764 divided by 5 multiplied by 4096 is 20480. Okay. Now if we cross multiply, what do we get? 4 multiplied by 20480 is, using calculator, 81,920 minus 1062880, which is 5 multiplied by 212576, okay, divided by 5 multiplied by 20,480. Now if we simplify this, 81920 minus this term 10628,820, using calculator, what do we get? Minus 10546900 divided by 5 multiplied by 20480. Now if we continue to simplify, we get minus 1054,690 divided by 10240. Now striking off 0, we get Sn is equal to minus 105469 divided by 1024, and this is the final answer. And that's it on geometric series. So today we learned what a geometric series is, how to identify it and calculate its sum using correct formula by assessing whether they are finite or infinite series. If you found this video helpful, please like, share and subscribe to my channel for more easy to understand simple maths lessons. If you have any questions, feel free to leave them in the comments section below. Thank you for watching. Keep practicing and see you in the next video. Till then, best wishes and happy learning.